Hello and welcome to yet another video. In this video, we are going to talk about something very simple and something also very interesting, and that is called the maps inside Java. So if you are familiar with the concepts of objects in JavaScript, or if you're familiar with the concept of dictionary in Python, then you will find maps to be very simple. If you're coming from C++ background, then maps are something very similar to what we have in C++ as unordered maps and ordered maps inside Java. So let me just create a new class again, and I will name it code sapien map. Code sapien, S-A-P-I-S-A-P-I, right? S-A-P-I-E-N, sapien map. Okay, so I've created a new class called code sapien map, wherein we are going to learn about the map interface. Okay, so the map interface is very much like how list interface is, but it is going to talk about a map. Now, what is a map? What is a map? So map is nothing but a key value pair. Map is nothing but a key value pair. Now, what is a key value pair? Let me just give you one quick example. So suppose, imagine that you are in school. Imagine that you are in school and you have a bunch of classmates. And because you have a bunch of classmates, every single person is having a roll number. Okay, every single person is having a roll number, and every single person is definitely having a name as well. Now, suppose you want to write, or you want to create a table, or you want to create a mapping between the roll number and the name. That is that maybe like roll number 1 is John, roll number 2 is Alex, roll number 3 is let's say somebody named Joe, roll number 4 is somebody named Taylor, roll number 5 is somebody named Miley, roll number 6 is somebody named, let's say, Justin, roll number 7 is somebody, let's say, with the name Katie, and so on and on. Okay, roll number 9 is somebody named Brittany, and so on and on. Okay, so this is what you want to create. So you want to execute a key value pair execution, right? You want to create a key value pair execution, wherein every key is corresponding to a certain value. It's like something versus something. Okay, so we want to create something like this. Let's say roll, and then we have name. Okay, so it will be something like John. So maybe, roll number 1 is John, John. Then maybe roll number 2 is somebody named Alex, and so on and on. Okay, so this is what we want to create. So this is when we would like to use the map interface inside Java. Okay, so map interface is again present in java.util package, and it is going to represent a mapping between a key and a value, wherein this is a key and this is a value. This is a key and this is a value. So you can get an item with the name of the key. For example, you can get like who is roll number 1, but you cannot get something like John's roll number is what, something like that. That is not possible. So we have a relation that is established from the key towards value. Okay, so we have a relation that is established from key towards value, something like this. So this is the type of relation that we have. So we have a relation that is established from the key towards the value. That is the relation that we have. So a map interface is present in java.util package, and it represents nothing but a mapping between a key and a value. Okay, a map interface is not a subtype of the collection interface. It is having its own interface, or it's like a completely new interface that is present inside the collections framework in Java. Therefore, it behaves a little bit differently from the rest of the collection types. Okay, a map can only contain unique keys. That is that you cannot have two people with the same roll number inside a classroom, right? Just like that, the keys that we write inside a map are always going to be unique, and it is going to use a technique called hashing. It usually uses a technique called hashing in order to implement this unique key structure. Okay, so that is the reason why it is going to behave a little bit differently from the rest of the collection types. Okay, and a map always going to contain unique keys. Okay, so now what is the main purpose of using maps? Okay, maps, like I just mentioned, they are one of the best ways of storing key value pairs. Okay, so I have mentioned right now that we can store something like name and roll number mapping. We can also store like maybe roll number and name and let's say a test marks marking. And we can also, like, for example, if I give you an example of Facebook. Okay, so we can give you an example of Facebook. For example, if I am friends with, let's say, 1000 people, so we can keep a list of all the people who are friends with Shantanu. For example, here we can write the name Shantanu, and over here we can provide a list of all the people who are friends with Shantanu, right? So that is something that can uniquely get me the idea of who are friends with Shantanu, something like that. So maps are perfect to use for key value pair association and mapping something like dictionaries. So if you remember, or if you're coming from Python background, a map is nothing but a Python dictionary, something very similar to a Python dictionary. Maps are used to perform lookups, by key, that is we are able to check for some value inside a map by using the key, or when somebody wants to retrieve or update an element by a key. For example, if I want to update roll number 1 by somebody named Taylor, okay, so we can immediately come to this location and update the value as Taylor. That is definitely possible. So these are the only two scenarios when using a map would be an amazing choice. Okay, some common scenarios would include that a map of roll number and name of students, right? A map of managers and employees, like for example, one manager manages how many employees and a list of all those employees. Okay, a map of roll number and names, like I've already mentioned. A map of something like zip codes and city names, right? So every country has multiple ways to uniquely identify a location. Like in India, we have something called pin code. In the US, we have something called the zip code. So using these zip codes, we can uniquely identify areas in our country. So we can have a map for that also. Okay, so that is the idea behind a map. Okay, so if you're coming from database background, you might also see or find it similar to how database columns are created. Okay, so that is how we can create a map, or that is what is the reason or why we would like to use a map. So the reason why we create a map is the way we would create a map is by writing map. Okay, not this, my mistake. We will write map, map, okay, which is again going to come from java.util package, and then inside these triangle brackets, which is called parameterized brackets, we will have to write the class which is going to represent the key and the class which is going to represent the value. So in this case, the class that represents the key is an integer and the class that represents the value is a string. And then we can write something like roll name map is equals to new hash map. So there are multiple types of maps: hash map, linked hash map, tree map. So there are multiple types of maps inside Java. So okay, so over here I'm using something called hash map. So hash map is the most simplest implementation of maps inside Java. So that is why we are going to use the hash map. Okay, there are more maps like linked hash map, sorted map, and tree map, etc, etc. So those are also the few things that we might have to see in Java, but over here we are going to use something called hash map. Okay, so let's try to see how we are going to implement a hash map. First things first, I would like to clarify a few things, that a map cannot contain any duplicate keys. It is not possible for a map to connect or to contain any duplicate keys. Okay, so any key can map at most to only one value. Okay, so you cannot expect one key to map, or like one roll number to map to multiple students over here. That is not possible. Okay, so it will only map to one student over here because the type is string. If you had written the type as list of string, then it would start mapping towards that list, even though that list is also one object only, but that list is internally containing multiple objects, right? So that is one thing we can have, but a map cannot contain more than one value for against one key. Some implementation of map may allow null key or null values like the hash map and linked hash map, but some may not allow, like the tree map. The order of a map depends upon what is the implementation of a map. So it would depend upon what type of map you are using. For example, if you use a tree map and a linked hash map, then they have predictable orders. That means that the values in this map will be based on how the values were added, or in what order the values were added. But in hash map, it is not at all specific. You cannot predict. Okay, there are two interfaces which are used for implementing a map, and they are called map and sorted map. And the classes that are used inside a map is hash map, tree map, and a linked hash map. So right now we are using the hash map function. So let's try to add elements inside this hash map. So like I had mentioned that a map is going to function slightly different from the main collections, and therefore to add something, we cannot expect something like roll name map.add. This is not possible. Instead, we have something called .put. Okay, so we have something called .put, and in .put we are going to accept, or we are going to pass two functional parameters, out of which the first one is going to be of type this class, which is written as the type of the key. For example, I can write 1, and over here I can write the name John. Okay, so this is like me adding a key value pair to this map. Similarly, I can write roll name map .put one second .put this, and I can write over here maybe what I've written, Alex. So I can write Alex over here. I can pass Alex over here, Alex. Okay, so I've passed Alex over here. One second. I passed Alex over here. So what if I printed system.out.println roll name map? So if I run this code, let's see what's the output. So when we run this code, you can see something like a Python dictionary, right? This is how Python dictionaries usually look. So they will be separated by commas, and over here, instead of separated by is equal to sign, they are separated by a colon sign. Okay, so here it is basically saying that 1 is mapped to a string called John and 2 is mapped to a string called Alex. Okay, so this is one function of adding a new element into a hash map. Then again, we are going to see something like dot contains key function. So dot contains key is contains key. Okay, so like the name of the function suggests, this function is going to return true or false on the basis of the fact whether this certain map is going to contain a certain key or not. For example, if I write 3, then the answer should be false because there is no key in the map which is mapping towards the value 3. Whereas instead, if I write system.out SOUT role name map dot contains key suppose 2, then in this case we should see the value as 2. The value is true because the key is definitely there. So let's wait for it to run. So in the first one we should see false, and in the second one we should see true. And that is exactly what we are getting. Similarly, there is a function called contains value, which is going to check if there is a value that is already present inside our hash map. For example, I can write something like Alex, A-L-E-X, Alex. So in this case, what should we expect? We should expect the value true. And in this case, suppose if I write over here Taylor, then in this case, we should expect the value as false. So let's run this code. Sorry, my mistake. I have written contains key and I have executed with the value. So it is my mistake. I need to rewrite this piece of code, and by writing contains value. Okay, so let me just run this. I'll run this code. Let's wait for it to run. And we can see the value coming as false and true because there is no value which is of type which says Taylor, but there is definitely a value which says Alex, and therefore we are seeing a true and false value. Okay, so this is how it's going to work. Then if in order to get an element which is at a certain key, we will use system.out.println, and then here we will use role name map dot get, just like we are going to use inside a list or an array list, right? So over here, if we write 1, which is the index, which is the key, then that is going to return me the value corresponding to that key. So in this case, it should print John. So let's wait for it to run. In case if we write a key which is not existing, then it will return null. Okay, it's going to return null. And you can see John is getting printed. So in case if there is a key that does not exist in the map, then in that case, it is going to return what? It is going to return null. So for example, if I write system.out.println, if I write role name map dot get, and if I write something like 10, then in this case, it should return a null value. One more thing that I would like to highlight is that there is again a function that checks whether the map contains any key value pairs or not. So I can write role name map dot is empty, which is going to return a boolean value which says that whether the map contains any key value pairs or not. If the map is empty, then it is going to return true. If it is not empty, that means it is going to return false. So it is a very self-explanatory code, which is one of the best parts about using Java. That is, you always get to see a code in such a way that it is always already understood by the name of the function. So I personally like Java because of this reason, because whatever code you are writing, you are understanding it at the same time because of the function getting so self-descriptive. So if I run this code, for the last output, we should see false getting printed. So if we run this code, we should see false value getting printed. So let's wait for it to run. And we can see definitely false value getting printed. And in the second last line, we can see null value getting printed. So this is how we can run our program inside Java, and we can see whether a particular map is empty or not empty. Okay, there is one more thing that I would like to show you. Suppose you only want the keys. Suppose you want a list of keys, or if you want a list of values, that is also very simple. You can always write system.out.println, and then you can write role name map dot get, dot keys set. Okay, so it is going to return a set, which is something that we are going to study later, but it is something you can imagine that it is going to be something like a list only, dot value, okay, dot values, something like that. So key set is going to return a set which is containing all the keys, and dot values is going to return us a collection, which is basically like a list only. So if I run this code, I should be seeing a list coming out of this place, and over here I should be seeing a set coming out of this place. Now, what is the difference between a list and a set? This is something that we will be seeing by the time we will be coming towards the next part of this video. So that was pretty much it from my side in this video, and I will see you in the next one.